decoherence is not the answer. And there is a standard way of looking at that. You see, you have a quantum system, which is a nice pure system with few degrees of freedom. You've got control of them. You know how the Schrödinger equation works, so on. You try to do an experiment, but then the air gets involved, or one way or other. The environment gets involved, and so you broaden it out into a bigger system. Then there's a standard cheat. The standard cheat is to say, okay, we have a good way of describing the decoherence and all that. We construct what's called a density matrix. Okay, that's fine. When you've got a density matrix, you have the freedom to rotate your description in a certain way, and you come back again and you say, okay, I've just changed the coordinates they use, and it's now become a diagonal matrix. These diagonal terms are probabilities, so that we've got it in terms of probabilities. Yeah, sure, but it's a cheat. It's a cheat because you don't have a consistent ontology of what the world is like. You start off by saying the world is described by a wave function, then you say it's described by a density matrix. Then you go back and say, now that's a probability mixture of wave functions. Sure, but it's not the same as the one you started with. So you slipped a little, I mean, all these arguments are a cheat. I mean, they're not put like, that's a bit rude to say it's a cheat, because these are clever arguments. And they sort of allow you to relax and say, oh, I see, that explains it. They don't. They certainly don't. That doesn't give you a consistent ontology or understanding of the way the world actually is, which is consistent with your description. You shift in the middle. You change your ontology twice. Once when you get the density matrix, and secondly when you make it a probability mixture of states. It's this different one from the one you started with. You look carefully at it, it's a cheat. It's a good argument. I'm not saying it's a bad cheat. It's a pretty clever cheat.